Welcome, wonderful listeners, to the very first episode of Pavement Matters. I'm your host, Lachlan McLean. Now, Pavement Matters is a show where we discuss the constantly changing and regularly surprising field of pavement and road technology to help you get the jump on anything new and useful in the world of civil engineering. Pavement Matters is brought to you by Pavement Management Services, one of Australia's oldest asset management consultants and pioneers of the high technology pavement engineering space. Today we're actually discussing one of PMS's original product offerings that is still well and truly in use today, over 40 years later, the Falling Weight Deflectometer. The FWD has become synonymous with pavement design internationally and has become just as eponymous with the concept as a geotechnical assessment. Chances are the majority of roads you drive every day have at some point been tested in this way. But why do people do it? What benefits does it give? And what even is it? And of course, all of what I mentioned just then will be talked about later in today's episode. But first, I'd really like to introduce our guest. His name is Firas. He is our main pavement engineer in New South Wales, probably the go-to guy for all FWD testing. He's spent at least 2 years working with the FWD and working under our senior engineers and knows quite a bit about it. So, Firas, how are you today?
Yeah, I'm good, thank you. How are you?
Yeah, beautiful. It's a wonderful sunny day here in Sydney, and I'm just glad we have lovely windows in this office so we can experience it somewhat. So excellent. Let's get right into it, shall we?
Yeah, let us.
All right. So first up, so what actually is the FWD and how does it work?
Okay, so the FWD is a falling weight deflectometer. It's a piece of machinery that's used in the industry to basically simulate an axle of a truck.
Okay.
So how it essentially works, it drops a load from a known height with a known weight at a known time interval. So basically it's under controlled conditions, which simulates this load.
Okay.
This simulation of an axle, so we simulate the axle of a truck just because it's one of the main factors that actually deteriorates our roads.
Okay, so regular cars don't deteriorate our roads very much at all, do they?
No, yeah.
Okay.
Yeah.
Huh.
So the heavier the vehicle is, basically cars are very, very, very light vehicles when you're comparing them to these massive road structures, and what's underneath, they're like a pebble on the surface, they don't leave a dent.
Oh, really?
Yeah, it's mainly trucks, buses, just heavier, larger vehicles that...
Dodge Rams?
Yeah.
Maybe. Electric Dodge Ram, maybe?
Yeah, maybe. But yeah, it's the heavier vehicles that actually leave an impression on the road.
Okay.
Yeah.
So you're really talking about the pavement deflecting here, and I don't know, I've always seen pavements as just being this big sort of slab of rock, essentially, that's just hundreds of kilometers long, and it's not really something that I really think of as deflecting much. Can you comment on that? Yeah,
no, as most people think, they look at a road and it's just this big solid object, which it actually isn't. So most of these roads around us, they're known as flexible pavements. Essentially, asphalt roads are flexible, whereas the concrete roads are more rigid. So when we talk about most of our local roads, they're flexible, and these impressions by trucks actually deflect the layers in this pavement. So there is very, very micro movements in the pavement.
Okay.
Yeah, and these are what are known as deflections, and that's what essentially the FWD is trying to pick up and trying to simulate.
Right, okay.
Yeah.
Cool.
Yeah, and to add on to that, these deflections in the roads over time can cause pretty serious problems. So we try to do these tests and analysis very early on into a road's life. These problems from the deflection of the pavement can range from a little bit of rutting on the surface, or to more severe problems like larger potholes and larger cracks, and it can really affect the structural integrity of the road.
Okay, so I guess the way that I've always sort of thought about it is that if you've got this piece of sort of thin plastic or or cardboard, and you're just, not really thinking, you're just bending it, fiddling with it. You might be sitting in a lecture or watching a movie or something, and you don't even know what you're doing. But over time, you're gonna just keep bending it, and eventually, it's just gonna snap. I suppose it's kind of similar for our roads, isn't it?
Because that's pretty much spot on. So those loads are the roads are under constant load, truck after truck after truck, at the same point over just a period of time. The road does need to be looked at for rehabilitation or just counter destructive measures.
So while the flexibility of the pavement is actually quite good for making the pavement more resilient, if say for example some water finds its way through the seal, softens the subgrade, and suddenly these deflections turn into massive bowl divot things, it's gonna eventually fatigue that surface.
So no, that's excellent. So that bowl that you mentioned, that is what we look at. So there is a deflection bowl basically analysis that we can do from the FWD tests. So the shape of the deflection bowl, it allows for a really detailed structural analysis of the pavement. Basically, the outer deflections from that bowl, they define the stiffness of the subgrade, while the bowl shape that's closer to the test point that we do with the FWD allows for the stiffness analysis nearer to the surface.
Okay.
So that bowl shape is, it's a very important shape for us to determine the different stiffnesses of the different layers.
Okay, so I mean, at the end of the day, even a flexible pavement is still pretty stiff as far as what I mean. Like it's not like a pillow.
No.
So we must be talking about some really, really minute little movements here. So how does the FWD actually pick those up? Because I imagine they're probably too small for the naked eye.
All right, so we got to probably dive into how the FWD machinery actually works. So essentially, it's a trailer component that carries this large weight that essentially has to be dropped at a point onto a loading cell, which goes onto a loading plate. This loading plate usually it's around 300 millimeters for our...
It's like dinner plate size?
Yeah, dinner plate size, yeah. That's just the standard that we use here in New South Wales and Australia for roads. I know if you want to test airports, you can get up to like 450 or whatnot. But yeah, that's just the standard there. That gets dropped onto that plate. That simulates an equivalent standard axle of a truck.
Right, so you drop that plate onto the surface of the road.
Yeah.
Okay, cool.
Cool. Onto the surface of the road at different points on the road, basically at the points that we want to investigate.
Okay.
Once we drop that, we got geophones that drop down onto the road, multiple. They can range from around 7, you can have as much as 12, depends on your plant setup. But basically these geophones are set up on the ground at different spacings to kind of create this bowl, if you can see what I'm saying.
Right, I see. And these little geophones, they're just like, I guess, if you think of like an electromagnet, if you think back to your high school physics days, there's a little magnet in a coil, and once the load plate hits the ground and causes the pavement to deflect, this magnet's going to deflect with it and move in the coil and produce an electric current.
No, exactly. So these geophones, they're positioned right onto the ground. So once that load drops onto the ground, they can pick up any of the movement that's happening on the surface all the way to the bottom layers. And these movements in the geophone are directly correlated to deflection in our data acquisition software on site. So we're able to get a live reading of the deflection and an inferred reading of the curvature.
Right, actually that's something I wanted to mention. So we've talked a lot about the deflection so far, which is I suppose like the depth of this bowl. But is curvature similar to that, or is that different?
So the curvature, like I was saying, is we can calculate it due to different geophones creating different, getting different deflections, measuring different deflections from the space intervals. So this will allow us to infer the curvature, so we can basically see the different deflection depth at different points, and this will kind of create a semi-bowl.
Okay.
If you can see what I'm saying?
Yes, I see.
Yeah.
Like half of the bowl.
Half of a bowl, yeah.
Yeah.
So that bowl, that half a bowl is also inferred to create a full deflection bowl. And from that we can continue our analysis.
I see. So if you have a geophone that's say 100 millimeters away from the point of impact, and you compare that to a geophone that's say 600 millimeters away from that point of impact, by seeing how the deflection is different, you can kind of infer the gradient.
The gradient, yeah, correct.
Yeah. So when you're looking at a road that's say the best possible road, what are you looking for in deflection and curvature values?
We're looking, so for a very stiff and strong and heavy duty pavement, we're looking at very, very low deflection and very, very low curvature. So a typical range is around 0.03 millimeters.
Yep.
300 microns.
Gosh, that is really, really low, isn't it?
Yeah, we're looking at into the micron level, so
yeah.
very, very low numbers. And from that we can also say a higher deflection and curvature usually means a weaker pavement.
Okay. So do you ever find that you have really, really low deflection but really, really high curvature, or vice versa? Is that something you get, or do they normally go hand in hand?
They normally correlate. So usually what we see in flexible pavements is higher deflections usually have higher curvatures. However, there is some cases that there is something in the pavement, like a surface or a pipe or something, and those numbers can...
They can fluctuate.
They can fluctuate, yeah.
Okay, all right. Well, actually, so we kind of have a good understanding now about how the deflection is measured, but once we have this data, once we've collected it, once we've taken it back to the office, what can we actually do with it? What can it tell us?
Yeah, okay, so it can tell us a lot. The first thing it tells us, obviously, we've got the deflection, we've got the curvature. We can start looking at different points of the road and basically back analysing from that data using the elastic theory model, basically. We can back calculate the moduli of each pavement, each model, each layer. We can calculate the moduli of each layer.
Okay, so the deflection and curvature really is just looking at the surface, but with that information, you're saying we can look at other pavement layers as well, because it's not just the surface layer that's moving, isn't it? It's the other layers, I suppose, to a lesser extent, that move as well.
Yeah, it's from the surface to your sub-base, subgrade, to your base layer. Everything's moving. We use all this data to infer a moduli for each of those layers. So we can actually calculate the stiffness at each of these layers for a certain point.
Really? Just from that surface data?
We also need some other parameters. No, not just from the surface layer data, but we usually need the profile characteristics of that pavement. So,
right.
So like the surface material that's under there, or the
thickness?
The thickness of the surface layer. Yeah, we can use that to calculate our moduli.
Okay, all right, beautiful. So it seems like you're pretty on top of the FWD. So in your experience, what kind of actions have you seen the FWD, like what have you personally seen the FWD being used for? Like what difference does it make?
Yeah, so personally I can take you back to not that long ago. We had a project for a client in the Sydney area. It was a large industrial area. There were severe problems with the pavement. It was failing. So they got us to come on site with the FWD. So they had to mill the current pavement.
That's just taking the top couple of layers off, isn't it?
Yeah, basically removing the top layers, and they had to relay it and resurface it. So before they did that, we were there on site, basically measuring the deflection and curvature at each point in that milled area before they can do any overlays. in real time, we were analysing and processing the data and giving the data to the client and letting him know which part of the pavement was of concern and showing very high deflections. So that on site, we also made the decision to patch certain areas before they overlaid it. So that's one of the real life, real time, in action sort of benefit of the FWD.
Really? So that was all done in real time?
All in real time, from the testing, processing, to the actual resurfacing.
Wow. Wow,
Yeah.
that's pretty impressive. So I know another thing the FWD I feel can be used for is it's quite, because essentially what you're getting with the deflection and curvature, you're essentially getting a measurement of the pavement's strength.
Basically.
Essentially, yeah.
Yeah.
So if you take one measurement of the pavement strength, say in April, when there's a big construction project going on,
Yep.
and you come back, say, June of the next year, so just over a year, construction project's finished, you could determine really what impact that this big construction traffic has had on this road by seeing what the difference of the deflection and curvature values is. If the deflection and curvature has increased by, say, on an average of 15, 20%, then you could pretty much infer that this big thing's had quite a bit of an impact on the road.
Yeah, no, excellent. That's perfect. So yeah, the FWD is used a lot in basically delap works, dilapidation. You want to know the current condition of the road, and then test in the future and see what differences a certain activity done to the road. So all the trucks that were used, let's say for an example, there was a project, used a lot of trucks. Before the trucks are even brought onto the roads, we will test the roads to get the current condition. And then after the trucks have used it, say after a year, we'll come back and we'll do the same test. And from that, we can actually see the difference in the structural capacity of the road.
And I feel like that's pretty good, because a lot of the time the thing about road structure is sometimes the structure could be suffering and there's no visible symptoms of it. It could look perfect on the surface.
Yeah, yeah. So a lot of
it won't be for long, but with deflection and curvature, it's possible really when you're measuring this stuff, you could kind of predict when a road is going to fail, can't you?
Yeah, yeah. That is correct. So this is where we'll jump into how the FWD is used in basically predicting the future, predicting the road's future state. So there's something that we can actually use with this data that we've collected using something called an empirical mechanistic remaining life chart design.
Yeah.
So basically what this does is it allows us to create a 20-30 year report of how the pavement is degrading over time with certain parameters. So we'll have to know what traffic is being so we got to know the future growth in traffic and the pavement surface thickness. And from that, we can generate a 30-year remaining life report, which basically tells us how long this pavement is going to last.
Okay.
And when we need to do remedial actions.
All right.
Yeah.
Cool. All right. So I'm pretty sure that's most of what we have to talk about, but it really seems like the FWD is a really versatile piece of equipment. Like there's so many things you can measure it. And we'll just say you're an aspiring sort of road manager, you're wanting to do the absolute best job that you can do. You've heard about this new FWD thing and you want to put it to use. So Firas, if you were to give this guy a quick summary of what it can do for you, what would you say?
Look, I'd say this piece of machinery allows you to produce a more realistic and accurate works program. It helps you manage your resources in a much more efficient way. And most importantly, it helps you get a more accurate budget for your road and give you the best client satisfaction experience for road users.
Okay, you can't ask for more than that, can't you?
No, you can't.
Yeah. All right, well, I'd just like to thank you very much, Firas, for taking your time out of your day and joining us with the podcast today. I really hope you enjoyed your time and just, feel free to come back anytime.
No, thank you for having me. This was very enjoyable talking to you, Lachlan. To experience road connoisseur like yourself.
Yes. Oh, you're all too kind. In fact, I think we should have you back for episode 2 as well.
You know, I wouldn't mind that. Thank you for having me. Thank you.
All good, all good. So everyone, we hope you're able to learn a lot about the FWD and what we do here at PMS today, and how it's used in the structural evaluation of pavements and how you can put that to proper use in your own network. If you do wish to learn more about the FWD, you can visit our website at pavement.com.au. We can get a free brochure on the FWD and a lot of our other services as well. Also, just let us know what you thought about today's episode with feedback, suggestions, episode ideas by shooting us an email or a message by LinkedIn. So LinkedIn Pavement Management Services, or email hellopms@pavement.com.au. So, well, this is actually our very, very first episode, and we hope you enjoyed it. So join us for episode 2 in the not too distant future. All right, see you later.